Joined now by Neda Cvijetic, Senior Vice President, Head of Artificial Intelligence and Autonomous Driving, AD at Stellantis, and Russell Kaplan, Director of Engineering at Scale AI, for a fireside chat conversation. Neda leads global AI and AD software engineering in support of creating breakthrough capabilities for all Stellantis brands and accelerating the transformation of Stellantis into a leading tech mobility company. Prior to Stellantis, Neda worked on autonomous vehicles, AI, and computer vision at NVIDIA, and was also the producer and host of Drive Labs. Prior to NVIDIA, Neda worked on autopilot and infotainment systems at Tesla, served on the adjunct faculty of Columbia University, and held senior research positions at NEC Labs America. She holds a PhD in electrical engineering from the University of Virginia, as well as over 20 granted U.S. patents and peer-reviewed conference and journal publications with more than 4,000 Google Scholar citations. Please welcome to the stage Neda Cvijetic and Russell Kaplan.
Neda, it's great to have you here. Thanks so much for joining.
Russell, it's great to be here. Congratulations on an amazing event. I hear over 20,000 people joining online, great in-person attendance as well. So congrats on that, and great to see you again.
Likewise, great to see you, and thanks. Looking forward to the conversation. I wanted to start off because we've worked together for a while, originally at Tesla on the autopilot team. Since then, you've had a lot of leadership positions at NVIDIA working on Drive, and now you're the SVP of AI and Autonomy at Stellantis. You've worked on small teams at startups, and now you're a leader at a 400,000-person organization, one of the largest global automakers with really famous brands like Maserati, Jeep, Ram. How has that transition been for you?
It's been fascinating. So back in 2015, it was the days of the NVIDIA Drive PX2 on your desk, and you are driving to NVIDIA in Santa Clara to pick up the said PX2 to put it on your desk. And the way that you scale training is by putting more PX2s on that same desk. What I loved about those days was this incredible feeling of you can do anything. Literally, you can do anything. You can enable yourself, this entrepreneurial can-do spirit rather than first principles, leading the charge in the industry. And that mindset is what I share with my teams literally every single day now. I want us to have that same mindset. What was really hard at that time, and what is hard, I think, for any startup in this space, is scaling. So the challenge of going from 5,000 cars per year to 50,000 cars. To 100,000 cars. And you have to get there because that's when you see these statistical gains in terms of the data that you can collect from your fleet. And that's where I think the power of Stellantis is, because we are 6 million vehicles per year across 14 brands. That means that 100,000 cars can be cranked out like that. And so that's why AI, I think, is so powerful for a company like Stellantis, because it's the fundamental leapfrog technique. If you have the data at scale, and the in-house knowledge to do AI, which we're taking in-house strategically, both for AI and autonomous driving, that's how you accelerate. That's how you leapfrog.
Yeah, I want to ask more about that because Stellantis has more than a century of history, right? One of the oldest automakers, and you're joining this large organization with a brand new effort, essentially, to build an in-house autonomy program. How are you building that from the ground up, and how are you doing that leapfrogging?
That's a fascinating question. So I think one thing that's really was very powerful to me at Stellantis and attractive was the storied brands. So I think when I was joining, I was almost like, wait, you want to pay me to put AI in the Maserati and the Jeep? Okay, no, that's not a bad idea. That's a great idea. So we have, I think, this amazing design history, incredible iconic brands. But then you have the engineering piece, like you said, that's new. And so what was very important to me is to build AI in an AI native way from the ground up. And to me, that meant thinking about infrastructure and tooling that allow you to scale from prototype to production grade, and thinking about that from day one. Because it's one thing running a small scale experiment, right? Getting some data quickly, getting excited. It's another thing to have continuous improvement and all the processes, all the versioning, traceability, and everything else in place to get to where you need to get to for production grade.
I want to dig into that because obviously, times have changed a lot since 2017, 2016, when we were assembling PX2 boxes by hand. I remember the Tesla offices getting very hot at the time because engineers were training all the models under their desks, and you could sort of tell what model you were training by the sound the GPU was making. That's a lot of convolutional layers right there.
Yeah.
But we've moved on a great deal. For you building this from the ground up, what are the most important components of AI infrastructure? If you look at the priorities of the infrastructure you're building internally, the infrastructure you're using, how do you evaluate how good it is, and what are your top priorities?
For me, my top priority is developer centricity. My top priority is my team. So my team is globally distributed. We've got hundreds of engineers in about a dozen different countries in the world. And for me, every single engineer has to have the same experience. So the same access to compute. They have to be able to basically, have a very efficient workflow. So different access levels, maybe depending on whether they're working on scheduler level or if they're doing Jupyter programming or if they're doing workflow level tasks. So being aware of that, having that front and center, and then designing that system in order to be developer-centric based on the team profile. So for me, on-prem, 100% on-prem, is not possible. We are not an in-person team in just one geographic location. We're not. That said, there are some certain parts of on-prem, the flexibility, the sandbox aspects, experimentation that we love, that we want to keep. And so for us, having a hybrid design where a part of this, maybe for more deterministic workflows or peak loads is in the cloud, but then you still have some flexibility in certain on-prem locations. But then again, designing things to be really optimal regardless of where you are in the world. Those are some things that were really, really key to design this right the first time.
So for that developer centricity, one thing we've talked about is easy to use APIs, easy to use integration points. And often building an autonomous vehicle program, as you've worked on 3 now, have a bit of experience with this, you define these API boundaries between teams. And I think this is not just unique to autonomy. This is very common in machine learning in general, that we have to define API boundaries between teams for teams to be able to collaborate together. And this has a lot of advantages because it makes it have thin interfaces between teams. You don't have to talk to everyone to know how everything works, and you can sort of code against a team's API. But one of the challenges has been sometimes machine learning works better when you do things a bit more end-to-end, a bit more integrated. If you have a very thin API between your planning and your perception stack, that can cause downstream problems, or can it? So what has your experience been like optimizing for developer centricity while dealing with the unique constraints of machine learning?
Another great question. There are beautiful things, as you said, with this modularity. It's clean, it's light, it's understandable. But you're right, maybe it doesn't tap into the full power of machine learning. I think on the other side, going too end-to-end can also be tricky. Because at that point, we have to be a little bit careful about any kind of black box type situations that might be tough. And honestly, we've seen that even on the embedded side. So back in the day, I think there was a lot of popularity of super end-to-end models on the embedded stack. So like video in and maybe some odometry information in and steering, braking command out, right? That's tough. The explainability of that is tough. And so there is some factoring, I think, that we've seen over the years is beneficial for that reason, for the explainability part, because we are in an industry that's heavily regulated, right? And honestly, there's a little bit of confusion, I think, from our side, from some traditional players about the safety of these systems, and I think that's why explainability and factoring things with that in mind is important.
So with that in mind, tell me about what are you doing sort of on board on the vehicle in terms of infrastructure? You're obviously doing a lot, in the cloud and on-prem for infrastructure, but what about on the vehicle?
We are, I think, in a very interesting time in terms of the embedded stack itself, because I think what we're going to see happening in the next couple of years, and we've announced this at Stellantis, with our level 3 plans in 2024, so bringing that to market in 2024, SOP, start of production, is an expansion of the operational design domain. But I think in a very exciting way, in a way where it becomes very clear that it's incredibly important for your onboard stack to have a very accurate, robust, AI-native, 3D understanding of the world. That's something we've definitely learned. I think a couple years back, we went AI-based, but we went 2D. So 2D space, right? And then make some approximations to go into 3D space. But I don't know if you've ever been in a car where, it's assumed that the world is flat and the world is not flat. It's not the most customer-centric experience. And so from that, we have learned, no, humans can sense in 3D, we need to sense in 3D. So I think we're seeing that for sure as a way to extend ODD, and also doing it in an increasingly dense way. So high resolution 3D understanding, kind of per pixel, let's say, depth estimation. More and more of these volumetric models, I think, are going to become more and more important, not just because you're facing situations where there's occlusion or something like that, maybe in more semi-urban and urban driving, but also because I think we're going to get into situations where a fixed number of classes, let's say, in your perception stack that worked really well so far in certain highway scenarios are not enough anymore. For L3, you could be facing arbitrarily shaped objects on the road, or even more unstructured environments, even if you're not on the road, if you're off-road or something like that. These are unstructured environments where I think now this really high-resolution, detailed 3D understanding is going to be fundamental in how you architect that stack.
So to dive in on that a little bit, which makes total sense to me. I remember seeing some edge cases where we would get clips of cars driving on the road, and you would see what looked like a flat continuation of the road ahead of you. And when you look very closely, it's actually a mural of a road that's straight ahead of you. And it was basically an adversarial example for humans. I don't know what monster painted this on some mural, but it can cause a lot of problems at the edges of the operational design domain. But Stellantis, to your point, has ODD challenges way beyond different roads. You make Jeeps, right? And so is there an off-road autonomy plan too? And how much does that stack look similar or different from what folks are doing for on the road?
Well, that's what's kind of exciting about doing this at Stellantis. You're not doing it for, let's say, one vehicle model or two or three, and then it's literally the exact same system, very similar brand-wise. It's 14 brands. Literally 14 brands, and so we have a full range from a vehicle that is very cost-effective, maybe costs several thousands of dollars, and like 4-digit number, not even 5, to a high-end Maserati, right? So the kinds of capabilities, the kinds of use cases that you can think of here are incredibly diverse and incredibly rich. And so the key thing, again, coming back to your earlier point, is how do you then design in a modular way where the fundamentals are transferable, but then still have a little bit of room to customize and to tweak to certain unique cases. And so that's why I think that this synergy between new operational design domains, whether they're extending from highway to semi-urban or urban, or L3 scenarios with these crazy corner cases, like you said, or even off-road, are so interesting. I think they're highly synergistic with each other because of these technical fundamentals, basically understanding the world in high resolution in 3D.
I think that's one of the big questions we've heard from a lot of folks in the room and online is, as we deploy machine learning in more and more different types of environments, how much of that stack should be shared? How much of that stack should be shared across environments? And how much should be customized, to the vehicle that it's being deployed on, to the customer that you're deploying at? And so what is your take there? Is the idea to have one unified autonomy stack that you can use for each brand with very minimal changes, or to do something more custom, for each brand and really optimize it for that case?
This is so fascinating to me because we have such a rich, iconic brand portfolio and such strong design history. That, I think, is where I see really beautiful collaborations between designers and engineers really coming to shine. Because that's where it's really important for us, to engineers, to truly understand and absorb the brand's core values. What matters to their customers? How do they perceive value? How do they perceive luxury? Maybe it's not about luxury materials anymore. It might be about a more proactive, predictive, personalized in-cabin experience. We also, within the team, have responsibility for in-cabin AI, for cockpit AI. So that's also a really interesting kind of domain along which to slice and dice this problem, right? It's not classic autonomy, but it's highly synergistic, because when the car's driving you, then what experience do you want from your cabin, from that 3D space that your phone cannot give you, right? So I think that that opens up a whole other set of really fascinating AI challenges to solve.
Totally, and I think this will become much more important as we get closer and closer to autonomy, because eventually, when all the cars can drive themselves, what's the difference? It's the in-person experience. Are you thinking about sort of customization of the driving profile, based on in-cabin signals, things like that?
Yeah, or possibly even, programming your car to have a certain driving personality, that is also not inconceivable. But what I also think about a lot is what needs to happen in the cabin to have a differentiated experience. So, we as humans, I think, have these really interesting capacities of intuition, of self-awareness, of awareness of the other person, of being able to sometimes predict what, somebody else needs. How do we model that, with AI? How do we structure this problem, knowing that, okay, we have different sensing modalities inside the cabin. You have visual, you have audio, conversational, you have, seat sensors, you have all these different tactile components. How do you combine that together? And one of the things that I personally wonder a lot is, does this open up early fusion type challenges or problems to be solved that effectively would approximate in a useful and practical and customer-centric way something like intuition and proactiveness and expressiveness, as we heard, I think an earlier panelist say today, that will make the difference for that, experience inside the cabin. So these are the kinds of things that I'm thinking about.
I want to dive into that fusion question, in particular in the context of maps. So there's been a big debate in the autonomous vehicle industry of how to use maps, or should we have high-definition maps? What's your take on that?
Map. So map, I think, is incredibly valuable. To me, a map, what is a map? A map is an ability to bring information from a previous drive into the current drive in a way that can be actioned. So I think you can claim that, okay, from when we do that, when we bring information from a previous drive into the current drive, we're just exercising the learning capacity that's modeled by training of an AI model. But that's not quite the case, right? Because static training is fixed. You can't now be retraining and learning at the same time and inferencing the new thing at the same time. We're not quite there yet. And I think you bring up a really good question there, because a lot of folks who are learning about AI have the impression that today's cars do this already, that they're driving in the world and they're learning as they go. But no, they're actually capturing data as they go, and then they offload that to that infrastructure, that school of AI that we talked about at the beginning, and then learn it there. But with a map, you can bring that into the current drive, action it right away. So honestly, I think it's a time travel sensor, because you're bringing the past into the present in a way that you can action it, but you're also predicting the future, because these maps can see longer than perception can. So yeah, I think it's a time travel sensor. You're bringing the past and the future into the present moment in a way that you can action it. So I don't see why we wouldn't be using that capability to drive better and to give our customers a more customer-centric experience.
I love that framing of a time travel sensor, because you can see in the future if you know what's coming. And to your point on how real time is the machine learning happening in a vehicle, this does seem to be a big disconnect, because even as we approach having models, neural networks that are more human-like in some ways, it totally belies the reality of how these models are deployed and then improved over time in these very fixed batches. And when folks say, hey, can we do real-time learning on the car? And there's interesting research on real-time machine learning models. But what it sounds like you've seen, and what we've seen in general, is how do you go about that from a safety and validation perspective, right? If you're going to do regression tests, if you're going to pass Euro NCAP, it seems really hard to do a deep degree of personalization.
Well, it gives you a non-determinism problem, I think, right? If you're letting the model just kind of learn, in real time, then that's the challenge I have right there. Whereas when you train a model, you fix it, optimize it, do your validation, and then ship it on the car, it's deterministic. I know that because I validated it to be, right? And so this is why it's nice when you have these multiple modalities, a model that's explainable and deterministic, plus a map that's in some sense independent of that, right? So there's a diversity component there that allows you to then factor and explain how this is robust and safe. And so I agree. I think it's a nice practical way to get to an approximation of real-time learning.
So do you think these maps should they be input into our learning systems, or are they something that should come after the fact?
Another great question. So I think we've seen some really impressive results in the industry lately on this, including the ability to actually in practice, because the theory has been around for a couple of years, but in practice set up this flywheel improvement effect between, let's say, your 3D perception and your map. So again, to me, if you are able to do that, actually implement it in practice where it mutually improves each other, then why not? I think it's a definite win-win. One thing I'm still confused about maps is what high definition means. Like, what does HD actually mean here? It's really not clear to me at all, but I don't think it matters. Make the map actionable for your stack, architect your stack in a way where it serves your purposes, and do it efficiently, and that's all that matters. So
are we going to have maps of all the off-road trails that you can take your Jeep onto?
I mean, opportunities are limitless, really. The sky's the limit. So I won't say more than that.
Looking forward to learning more. I think that has been one of the interesting things in general with all the progress in machine learning, is that so many problems that seem intractable at the outset with sufficient scale can be overcome. And we've seen that from many previous panelists on the topic of large language models. There's certainly an element of that discussion in the concept of mapping the world. It seems like a Herculean task, but maybe for companies of massive scale, it is totally feasible. So then shifting gears a little bit to large language models, it seems like everyone working in AI is thinking about them to some degree right now. Do you see any role for large language models in autonomous driving?
Also very interesting, and yes, you're right. A lot of conversation about this, a lot of really different and interesting use cases discussed recently. I think that we have a couple different options. One, we could think of using them also in the cockpit space, to have maybe better understanding of intent or something like that. In the autonomous driving space, again, also very interesting. Ultimately, I think, to me, it comes down to ensuring that we're focusing on the customer-centric outcome. That's really, really important in the way that we are doing it at Stellantis. We are, not really focusing on deep tech for the purpose of deep tech. So I understand that, large language models might be the thing of the day, but ultimately what we're after is the customer-centric experience. So if a large language model can solve it, great. If I can solve it a different way through, thresholding, some simpler operation, then I'll do that, probably because you know how it is with embedded compute. It's like beachfront real estate. It's true. There's never enough, and sooner or later, all the teams want a piece of that. So I think it's always a balance of how you slice and dice something, how you experiment something. But I think it's very exciting, and I really enjoyed the conversations, including today, on this.
So what do you think? As someone who has solved this problem multiple times or worked on this problem for a long time and now kind of building it up from the ground up again, is there anything that you're doing really differently?
Well, I think that what the opportunity is for us now, starting this and building this, is that there are best practices in the industry that didn't exist, in the days of PX2, when it wasn't even clear that we're going to move in this direction. It wasn't a thing. We were at the forefront of something, and we felt incredibly excited, but nobody really knew how it's going to turn out. Now it's a thing. It's an industry. It's established roadmaps. It's best practices. It's something that's making its way even into regulatory frameworks. There are committees on even how you treat the data for this, AI bias, AI ethics. And there are also there's been a tremendous increase in the support in terms of partnerships and ecosystem support that you can get to bring this to scale, right? Again, it's not just you with the warm PX2s and, maybe even labeling your own data and, doing experiments that way. So I think that's, in some sense, a really, really exciting thing, that the ecosystem and the capabilities and the speed with which you can turn something around when you have a direction that you want to go are really great.
I'm super curious on one facet of this point, which is as you've been building this from the ground up, one of the things you've had to do is build an AI team, more or less from the ground up at Stellantis. And I think there's a lot of leaders in the room and watching who work at all sorts of companies, some of which are really known for machine learning and artificial intelligence, some of which aren't, but are increasingly investing in that area. And one of the things that's been really cool for me to see, getting to know you, has been how fast you've built such an incredible team working on AI at Stellantis. So what is your advice for leaders in the room who work at maybe more traditional companies thinking about building world-class AI organizations? How do you attract the talent?
Oh, that's an excellent question. For us, as I mentioned before, we're very committed to the fact that we are a global team and a distributed team. So we are not only in one location, we are global, we are distributed, we support remote, and that has been very, very powerful in terms of hiring talent and growing talent and working with talent wherever talent is to be found, because talent is distributed regardless of geography. So that is one thing that I think has worked really well for us. And so I would definitely say that that's something incredibly important. And then the other thing is, you know, AI engineers, AI and machine learning engineers, and engineers in general, they're very creative people. They're very intelligent people. It's incredibly important to give them that space to breathe, to create. We've done really well when we have hired people who get excited by this notion of a blank canvas, who are not nervous or anxious about building from the ground up because they have this vision of how to do things, because they know from previous experiences, you know, what is important. And so that's what I would say. You know, sometimes the most important thing is to bring that person in, give them that space, and watch them work their magic. They're smarter than me. Give them that space. And so that's what we do, and that's what I would say also works really well.
Thriving in the blank space, thriving in chaos.
Yeah. They create structure, and it's incredible watching them. It's like an artist doing their thing.
Hopefully, almost as good as a DALL-E 2 or a Stable Diffusion prompt. You know, looking something really nice. So I guess to ask, so one final question. You know, you've, in addition to all the work you've done on autonomy and AI, you've also been an inspirational leader to a lot of folks who are students throughout your career. And so, what is one piece of advice you would give a current undergraduate or even high school student who's interested in working on autonomous vehicles?
I would give the advice that really was life-changing for me when I was in college. And that was, college is about learning how to learn. Okay, yeah, your subject matter might be electrical engineering or whatnot, but this is not about that. This is about learning how to learn quickly, effectively, accurately. And I think that's especially important for students in AI and autonomy, because this field changes so fast, as you and I have talked about. I mean, every single day I hear it's the new era of AI. Well, it is, and it will continue to be, like pretty much all the time, because it changes so fast. And so I think that skill of learning really fast, efficiently, and being comfortable with that will serve the students, and honestly, it serves me even to this day. And so that's what I would say. Let's learn how to learn, and then it'll serve you well your entire life.
Learning to learn. Is it a motto for students or for our neural networks?
Oh, I like that, Russell.
Maybe
oh, that was good. That was good. That's some of your finest work right there.
Thanks, Neda. Thanks so much for joining. Really great to have you. Big hand for Neda. Thank you.